last video of the day. Here's our story problem for hyperbolas. So we have, I'm going to read this really quickly. Hyperbolas have real-world applications in a lot of fields. Hyperbolas can be used to model paths of comets. They can be used to map supersonic booms, ancient Grecian pillars, and natural draft cooling towers. That's actually the one we're going to be looking at in our story problem. The design efficiency of hyperbolic cooling towers is particularly interesting. Cooling towers are used to transfer waste heat into the atmosphere and are often touted for their ability to generate power efficiently. Because of their hyperbolic form, these structures are able to withstand extreme winds while requiring less material than any other forms of their size and strength. So there's some hyperbolic cooling towers, and you can see the hyperbolic branches right here on them. And then they just cut the branches off at specific points, and that gives them their hyperbolic tower. So we're going to look at a cooling tower that follows this model. So you can see our hyperbolic branches right here that go on and on forever and ever. And then we specifically cut those branches off right here and here to make our cooling tower. Notice that this is not symmetric. The center or our vertices of our branches would be right here. So this is 79.6 meters, whereas this is 100 meters. So the vertices, it is not symmetric up and down, is what I'm trying to say. It's symmetric side to side, still with the hyperbolas, but not up and down. Now what we're going to do, let's see, read the instructions. Find the equation of the hyperbola that models the sides of this cooling tower. So first thing we need to do is take our cooling tower and we need to give it a coordinate grid. So here's what I'm going to do. I'm going to make this my x-axis, and I'm going to make straight down the center my y-axis. The reason I'm going to do that is so then the origin is my center, so I can use my center of 0, 0. So now that I've got that drawn, let's do all our hyperbola things. Vertices, conjugate axis, foci, and asymptotes. So I know my center is at 0, 0. I know my vertices, if this whole thing is 60, then I'm going to go out 30 on each side. So that's my transverse axis is 30, and my vertices are at 30, 0, and negative 30, 0. And this transverse axis is right there on the x-axis, so that is at y equals 0. Doesn't look like I know what my conjugate axis is because I don't have a guide rectangle drawn. So I don't know my foci. They're somewhere in here, don't really know where, and I don't really know my asymptotes. Kind of seems like I don't know very much. However, there are a couple things I do know. I do know that these hyperbola branches go side to side. So in my equation, x is going to come first. So that's my final answer. That's the equation I'm trying to get to. I know I can fill in h and k, and I can fill in my transverse axis. I know that. So it looks like the only thing I don't know for my final answer is my conjugate axis. So what I'm going to do is come back to this cooling tower and find a specific point on this cooling tower that I know. Meaning I know this point right here. I can label what this point as, x, y. I know the x is the side to side. So if this is 72 wide, then side to side is going to be 36. And I know that the up and down to that point is 79.6. So let's use this as an x, y point. plug 36 in for x, plug 79.6 in for y, and then I can solve for my conjugate axis. So let's try that. Let's simplify this first. This is x squared over 900 minus y squared over something, don't really know what that is, equals 1. So we're going to plug 36 in for x and 79.6 in for y. And then I'm going to zoom in here so that we can solve for our question mark. And that's going to give us our conjugate axis. So 36 squared over 900, so that's going to be 1296 over 900. Minus 79.6 squared is 630, 336.16 over my question mark. So I'm going to minus this one first. So I've got this, oh, forgot a 3. And I can just put that into my calculator. It should simplify to negative 11/25. Now I'm going to times by my question mark so I can get it out of the denominator. So I've got negative 6336.16 equals negative 11/25 times by the question mark that I'm solving for. So last thing I can do is times by negative 25/11 to get the question mark by itself. And I find that my question mark is the square root of 150. Oh, hello. Is 158,404 over 11, which is about 120.001. So I'm going to use my exact answer because that's what I like to use. Try to be more exact in my answers. Come here, erase. There you go. So that means this is 158,404 over 11. That's my question mark that I solved for. And at this point, you are technically done. Because it asked us to find an equation, and we found an equation, you could go through if you wanted extra practice and try solving for all of these things that you need to, but you don't really need to do that. So I'm going to call us done and finished, and we are finished with hyperbolas, which means we are done with Chapter 5. So you are now ready to start your very last Chapter 5 homework. Good luck.